Thank you, Delphine. And it's marvellous to see a packed Aurora Theatre this morning. Thank you for your interest. So I'll kick off today's proceedings with a talk on abrupt change. And you'll be hearing a lot about the abruptness of change that we're seeing as we move through the presentations today. It's going to be a recurring theme. With that in mind, I thought I'd start with one very simple take-home message, and that is that the emerging evidence you will see of abrupt change, it really marks a very worrisome departure from the convention of gradual change. And with that departure, what that does is it dramatically shortens the time that we have to plan for, but also to respond to the climate crisis. So that's really, I think, something to sort of take home with you today. And as you'll see, and you can see in the image here, the inextricable linkages we have between the ocean, the atmosphere, and the cryosphere, the different states that we have the ice in, makes this a big challenge to try and tease apart what is driving abrupt change. But also what it does is it also gives rise to a sort of a ripple effect where we see abrupt change, a little bit like dominoes moving through the system. And I'll give you a couple of examples of that today. Other speakers will dive into the detail. So thank you. And so I thought I would start with a figure like this. This goes back to, I said, this departure from this convention of gradual change. You've probably all seen these. This is from the last Intergovernmental Panel on Climate Change, the IPCC report, AR6 in 2022. What you see here is the past, the present, and then moving into a range of different futures. This is the amount of global temperature change in the atmosphere. These are a range of scenarios, from particularly frightening, a very high emission scenario, 6 degrees of warming, down to what we're currently aiming for, 2 degrees or less of warming. The other thing to note then are these are the outputs from a whole range of models, from CSIRO next door, right across the world. The amplitude of these different curves, the sort of colored area, that represents the... No, it's fine. That represents the consensus view of the models. But the key thing to take in from this is we have decades in which to maybe plan for and prepare for and respond to this gradual change. But yet we're seeing abrupt change now. Change not on decades, but on years. And that again comes home to my initial message. So it's very sobering, and I thought this was a good place to start to really say, no, there's been a shift in things, and so we'll step through that now. And so scientists across the programs represented there in the panel kept seeing evidence of abrupt change, not just in the cryosphere or in the ocean or the atmosphere, or indeed with marine life on the continent or in the Southern Ocean, so much so that they decided to put together a synthesis paper to try and raise awareness on this issue. This was led by Nerily Abraham, who is the chief scientist with the AAD, who can't be with us today. But this was really an opportunity then to show not only the diversity of abrupt changes, but also then the interconnectedness. And you see that coming through in this cartoon here, where, to say, everything is interconnected, from the ice sheets, the ice shelves, the fast ice, the sea ice moving out into the ocean, the overlying atmosphere, all intimately connected. And that really does, as you'll see, pose a big challenge to deciphering and interpreting what's happening. Before we go any further, I thought I would actually then give you a fairly sober definition. This is from the IPCC. A change in a system that is substantially faster than the typical rate of changes in its history. I have another definition which I think is particularly spooky, and that is the abrupt change is what we're seeing with postdocs and postgraduate students bearing witness to abrupt change during the timescale of their PhD or the project. So someone in a 3 or 4 year project is actually saying this fundamental shift. And that to me really is shocking. When we wrote some of the proposals for the research funding, we did mention that about the likelihood that we would probably bear witness to some of these abrupt changes. We hoped it wouldn't be true, but that's the case. So that's really what we're talking about. So I'll move to the first abrupt change, which some of you will probably be familiar with. This is what's happening with sea ice. The scale here is in millions of square kilometers. So just to give you an idea, the scale bar here is about the aerial extent of Western Europe. That's sort of some of the shifts that we're looking at. And here we see, this is a mix of both a modeling reconstruction, but then the satellite observations from the 70s onwards. What we see here is, with some noise, some environmental wobble between years, suddenly, abruptly, we move into the middle of the last decade, and we have this rapid decrease in sea ice extent. You can see it on the map over there. If you look at some of the posters next door, they're using scale bars like Western Australia. That's the sort of changes in aerial extent we're talking about. So, as I say, think back to the slide from IPCC. We have decades to resolve this. No, we don't. Abrupt change, it's very confronting. And of course, there was a puzzle for many decades because, of course, if we look to the north, if we look up to the Arctic, this is the maximum of sea ice, the minimum. If we look to the Arctic, things have been changing there since the 80s. But we see then that even though they've been changing rapidly, if we look at the slopes of the line for both the maximum and the minimum, we see that suddenly Antarctica is playing catch up. Suddenly we're looking at very similar orders of change in terms of the loss of millions of square kilometers of sea ice. And that in itself has been a bit of a puzzle about why we were seeing it at one pole, but not at the other. So we've played catch up. And there was a document released a couple of years ago on thin ice. You may have read it. It was released by the organizations organizing this event. And this is just a summary of some of the ramifications, some of the consequences. And again, this comes back to this interconnectedness of the ocean, the atmosphere, and the cryosphere. We see that the cryosphere, by holding lots of frozen water and also acting as a platform for marine life, it has these wider implications. You're going to hear more about that today from Steve Rintoul, but here's just an example of some published work. And this is the story in terms of the Antarctica is almost like Grand Central Station in terms of the pathways of ocean circulation. We form this deep ocean Antarctic bottom water current that moves all across the planet. And again, it has very humble beginnings, as it were, in some of the meltwater in some of these regions. So again, you can see a consequence of what's happening in the cryosphere is this knock-on effect then into the meltwater. But as I say, Steve will tell you more about that. Coming back then to this central figure from the paper narrowly led here again, the other connection that I'm just going to make now, there isn't time to go further, is between sea ice extent and marine life. And again, going to the Arctic, we were aware and have been aware of sort of confronting images like this one of a polar bear and severely compromised habitat here trying to move between ice flows. Again, this was driven by this rapid decrease in sea ice extent, but it's happened now in Antarctica. I'm sure you've all seen this from the New York Times or from the Guardian website. We did have these catastrophic breeding failures, which again were linked to the availability of sea ice as a habitat for shelter, for rest, and to really drive these breeding cycles. And so one of the challenges we have as scientists is not only to bear witness and to communicate this, but then to try and tease apart what's actually going on. And again, this is a figure from the synthesis paper. Again, we can see then we have sea ice decline. We have then these biological regime shifts. some of which may be irreversible. And what we can start to do then is start to look at some of these feedbacks. And again, we think some of the reason for the abruptness is linked to some of these very powerful feedbacks. In this case here, we have habitat loss and the failure of sort of breeding cycles taking place. And this is not just in isolated areas. Because of the conspicuous disturbance on the sea ice that the emperor penguins make, we can track this from satellites. So we see this is really truly circumpolar and is ramping up. So we've got this compound problem right around Antarctica that's taking place. There's not time to go into it today, but this is just one example of these so-called regime shifts and issues. There are others happening on terrestrial and also in marine systems. So it's not just emperor penguins, but again, no time to really go into that today. And so, again, what we tried to do in the synthesis paper then was to take the cryosphere, ocean circulation, changes in sea ice, and then link that with the biology. I'll step through this bit by bit. It ends up being quite a complex set of diagrams where we have both feedbacks and then we have actually feedbacks on the feedbacks. We can see here, when we start to look here, that ocean heat is causing increased melting in the ice cavities. And again, we see a feedback here where the meltwater from this increased ocean heat inhibits then the formation of dense water formation. And again, you start to see this complex circuit diagram being built out from here, where we start to see then effects from the sea ice, effects then again on in terms of things like wave disturbance affecting other parts of the cryosphere, such as the ice shelves. And so this really, I think, is a challenge. As I say, you will hear us bearing witness today to this fundamental shift from gradual to abrupt change. Now, what we're trying to do in the various programs and through the collaborations between the programs then is to start to build up this conceptual picture and then start to probe it to try and understand when you have feedbacks on feedbacks, that's the sort of environment in which you will see very abrupt changes. And that's where things are at the minute. So hopefully, as I say, just to take home then again of this move away from the convention of gradual change to that of abrupt change. Thanks.